Hi guys, happy Thursday. Now that you have completed the check of your activity choice, we are going to go ahead and write some WWKs and key concepts in your IMB. If you don't have it near you, please pause the video and go get it. Our first WWK is wave. A wave is a disturbance that transfers energy by repeated vibrations. Please pause the video and write that down now. Our second WWK is medium. A medium is a material or substance that energy travels through. Please pause the video and write that down now. Now, waves can be classified by a couple different ways. One way that waves can be classified is by their medium. The third WWK is a mechanical wave. A mechanical wave is a wave that requires a medium to travel. Examples of these are sound, water, and earthquake waves. For example, sound cannot travel in space. There is nothing in space. There isn't a medium there. But as soon as it hits our atmosphere, you can hear sound because it's traveling through the medium of our air. Same thing goes with water. A water wave can't travel unless it's in water. An earthquake wave can't travel unless it's traveling through Earth's surface. Please pause the video and write this one down. The fourth wave or the fourth WWK that explains how waves can be classified by their medium are the electromagnetic waves. So an electromagnetic wave is a wave that does not require a medium. However, it can. For example, light waves. Light travels in space, even though there's not a medium there, but as soon as it gets to our atmosphere, it also continues to travel when our medium is air. Other examples are radio waves, X-rays, and UV rays. Please pause the video and write this down now. Mechanical waves are waves that can be classified in two different ways. So the first way is a longitudinal wave. A longitudinal wave is where the particles travel parallel to the direction of the wave. That means the direction the wave particles travel is the direction the energy is traveling. You might know these as compression waves or maybe slinky waves. The picture is right here. So the wave moves left to right, and the slinky will also move left to right. You can see that in these type of waves, you have your compressions, which are parts that are pushed together, and then you have your rarefactions, which are the parts that are spread out. Please pause the video and write this one down. Transverse waves are another type of waves where the particles move perpendicular, that means at a 90-degree angle, to the direction of the wave. So the particles move up and down, the wave will be traveling left and right. Transverse starts with a T, and I remember this because T's make 90-degree angles when you draw them. So in this picture right here, the person is shaking the slinky up and down, but the slinky is moving left to right. And the picture right here with the purple wave on it, that kind of identifies some of the different features of a transverse wave that you may have learned about before. Please pause the video and write this definition down. Now we'll talk about what those features are. So the first one is frequency. Frequency says that it is the number of waves that pass a point in any given moment of time. This can be measured in hertz, which is abbreviated with Hz. So if I look at this picture, start here, one complete wave, two complete waves, three complete waves. So this would be 3 waves per second, and that would be measured in hertz. It would be this as a wave of 3 hertz. Pause the video and write this one down. The next one is wavelength, distance from one point on a wave to the next identical point. So whatever the distance units you are using become the units for the wavelength measurement. Some people measure it crest to crest, some people measure it trough to trough, some people measure it from start to next identical point on the wave. Doesn't matter, it should all be the same. Please pause the video and write this one down. Amplitude is the next feature we're going to talk about. Amplitude is the distance of the particles from the resting point, in this case they call it the equilibrium, to the crest or the trough. So trough to equilibrium or resting point, that would be the amplitude. It should be the same as equilibrium to crest over here. Whatever distance you're using to measure, those become the units of the amplitude. Please pause the video and write that down. Now we'll wrap up with some key concepts. The first key concepts. Waves are classified by their medium. That means they're either mechanical or electromagnetic. Remember, mechanical, they need a medium, and electromagnetic do not need a medium. Please pause the video and write this one down. Waves are classified by how they travel, longitudinal and transverse. Remember, longitudinal is where the particles and the energy travel parallel. Transverse is where they travel perpendicular or in the T shape. Please pause the video and write that one down. And the last one is waves carry energy, not matter. So a good example is that when you see a slinky, when you push energy in a slinky, you can see that it's carrying the energy, but it's not actually moving the slinky. So if you anchored a slinky from one side to the other side, you'd be able to see the energy, but not actually move the slinky as the energy is moving. If you need to pause the video and write this one down, go ahead. Otherwise, that's all we have for today. We miss you guys so much, and we hope to see you soon. And if you have a moment, watch the FlowCAD video. It's really good. Thanks. Bye.